So the next operator I want to talk about is the implication. So the implication is false when P is true and Q is false. Otherwise, it is true. That seems kind of weird, so let's go into a little explanation for it. But before that, just quick side note, the P in this case will be called the antecedent, and the Q in this case will also be called the consequent, which is names given for both of those statements. Another word for antecedent is the hypothesis, another word for consequent is the conclusion, if that's easier to interpret those words. Okay, so now let's look at the truth table for an implication. So here we see everything is true other than what I mentioned was when P is true and Q is false. Then the implication of P on Q is false. So why is this? Well, let's take a look. I'm gonna use an example where my prof used that was just ridiculous. So I'm just gonna use it anyways. It was so ridiculous. I loved it. So pretend you're a politician and you say this statement: if I'm elected, taxes will go up because I'm gonna get elected because of this, of course. So, now imagine if I'm elected as P and taxes will go up as Q. So here, when he says that if I'm elected and taxes will go up, if both of those things happen, it's true. That's fairly simple, right? Now, if he says I'm elected, but his taxes don't go up when he's elected, then the statement he just said is false. Now, if he says he's elected, but he doesn't get elected, and then his taxes go up, or the taxes go up anyways, then he didn't really lie to you. He just said that taxes will go up. Therefore, it went up and it is true. But it didn't really matter that he was elected or not. The taxes still just went up. Therefore, it is true. Now, for the last one, if he says that he wasn't elected, and then taxes didn't go up anyways, then again, he didn't lie to you. It didn't matter if he got elected. Taxes went down even though he didn't get elected. So that means that the statement is still true because he's not lying to you in a way. In this case, though, he lied to you. That's why the statement itself is false. And that's just basically the explanation behind implication. It's a little bit confusing, but a little bit of practice will take you a long way. Now, I'll go over the biconditional operator. Now, this is true when both P and Q are the same. So here we can see that the truth table for it, that just shows that both of them have the same value, therefore it is the same. So let's just do a little quick example for this. So say we had a triangle. A triangle is a triangle. It is a triangle. Oh, sorry. It is a triangle. Wow, I've been at this for a while, apparently. If, and only if, because remember, they both have to be the same, it has three sides. So that means, as you can see here, both these statements are true. Something is a triangle, and a shape has its three sides. And you can see that they both, how it works, because the biconditional operator just means that it's if and only if. So when they're both kind of relate to each other that way, then you know they are the same statement. Therefore, when they're both the same statement, the whole statement, or the biconditional statement is true. Alright, so now I'm just going to talk a little bit about translating to English. So, normally when we get a compound proposition, so when we take a lot of these propositions and then put them together with these operators, we tend to translate them into an English way. So let's just go over a few of these. The first one we have is and in an English sentence can be written as and or but. So if something says has two implications, have a but between it or an and between it, then you have and statement. An or is just or, that's very simple, and then you can read the rest. Implications have many ways to translate to English. These are just a few, but quick Google search will probably get you a few more if you need it. And then a biconditional is if and only if. Pretty simple. So, let's just go over one quick example. I've declared these variables to be propositions. So I said let A be my house is locked, let B be my house got robbed, and let S be my guard dog is at the ready. So let's say I wanted to represent this formula right here, right? So I said not B if and only if A or S. So what I said here was my house will not get robbed if and only if. Now A is my house is locked. If my house is locked, or my guard dog is at the ready. So basically what I just said is the only way my house will not get robbed is if I lock my doors to my house or I have a guard dog that is at the ready. That is a dog. Because everyone has a guard dog that's going to keep their house safe. So that's basically what you need to know for propositional logic from this week. Next week, I'll turn it over to Taz. He'll take you through some more stuff. I don't know yet because I haven't learned it. So thanks for watching.